There's just something wonderful about electronics that anticipate our needs before we even think to take action. Whether your hands are full or the light switch is hard to reach, having your workbench light up as you approach is a great convenience. LED strip lights and Arduino are both commonly available parts, but they don't play well together voltage-wise. But you throw in an Arduino relay shield and you have a solution, lighting that senses your presence. This project uses a PIR or passive infrared sensor. These sensors are used in most commercial motion sensors, but they're also cheaply available and they work well with an Arduino. The sensor works by detecting changes in the background infrared radiation emitted by all objects. We'll use the sensor to track movement and, when detected, throw the relay to activate the lights. You'll need the following parts to build this project. It shouldn't take you more than a few hours to complete. And you'll need the following tools. We'll start by building the connecting wire for the lights. Using a piece of hookup wire, connect the positive terminal of the LED lights to the center pin of the DC jack. Then, solder one wire to the negative terminal of the LED strip and another to the sleeve terminal on the DC jack. Wire these two loose ends to the COM1 and normally open 1 terminals on the relay shield, and then tighten the terminal screws. Now we'll wire up the PIR sensor. If you haven't already, fit the relay shield onto the Arduino board. If you have the right jumper wires, you can skip out on some soldering, but either way, connect the voltage in to a 5-volt pin on the Arduino, the middle pin to digital pin 10, and the ground pin to any open ground pin on the Arduino. We're functionally complete at this point, so it's a good time to upload and test the code. Connect the Arduino to a computer and upload the code to the board. Once loaded, open up the serial monitor. You'll notice that the PIR sensor takes around 45 seconds to initialize before it can sense motion. Once it is active, wave a hand in front of the sensor to check it, and even if you don't have the lights powered, you can verify that everything is working by listening for the click of the relay. Once the code is loaded, we're ready to finish the installation. Mark and cut a hole that fits the PIR sensor in the enclosure, then drill a hole for the DC jack and another small hole to run the output wires through. Using some thin strips of double-sided foam tape, mount the PIR sensor to the inside of the enclosure. Install the DC jack and fit the wires through the other hole. Next, you'll connect the Arduino to power using a 9-volt battery, and if the enclosure is getting cramped, you can save space by soldering the battery clip wires straight to the barrel connector terminals on the board. Supply power to the LEDs by connecting the power supply to the DC jack in the enclosure. Check to make sure that the PIR sensor is triggering normally and mount the lights where you need them. Now you have smart lighting for whatever you need. While hands-free lighting is very useful, we can imagine a lot of different adaptations for this project. Let us know what you build in the comments section below, and check out makezine.com for more projects, tutorials, and maker inspiration.